Hello everybody. For today's assignment we will have to draw multiple parts and then assemble them together. We have the base, the slider, okay, the crank, the rod and some pins. All the dimensions are in inch, and today we don't need to create the 2D drawing file, and we'll basically learn about how to assemble multiple parts together, and then we will do some analysis. We'll see the simulation of the motion, and we will basically learn about motion analysis today. For this full assembly, we will have total 6 parts: the base, the crank, the rod, the slider, and there will be 2 pins. The first one is the base. So I'm going to open the inventor and then I will start this drawing of the base. So for drawing the base, first you need to click on the file, then click on new, and then find the English template. You can expand it and find the English template, standard inch, and then click on create. The first thing you need to do is to see the dimensions. So you can see the dimensions here. Okay, so what can you do? First you click on the 2D sketch, okay, and choose any plane. I'm choosing XY plane for this time, and then under the rectangle we will find the slot. The center point slot will be useful for this drawing, so I'm choosing this one. Then click on the center, move your mouse, keep it straight, and click again, and move your mouse to the up and click again. So I've just drew a random slot, then add the dimension, make this length to be 0.5 inch, 0.75 inch, sorry, 0.75 inch, and the radius, you can show you, the radius should be 0.5 inch radius. So use the dimension to make the radius of this one 0.5 inch. Okay, and after that you need to draw a circle. The circle's diameter is 0.5 inch. Again, at the center point draw a circle 0.5 inch. Okay, now finish the sketch, and the thickness is here, you can see 0.25 inch. So you extrude this, click here, and make this 0.25 inch. Okay, now you need to save this file, and go ahead, save. Okay, click on save as, and you can give a name. Give a name like, I'm going to choose the document folder for this documents, and give a name, the base, BASE. Okay, save. The next one is the crank. Okay, for making this crank I'm following the same way. Start a new sketch, new, choose English standard inch template, click on create, and then choose XY plane and start a 2D sketch, and you can choose the center point slot again. Click on the center point, move your mouse to the left or to the right, but keep it horizontal. Click again, move your mouse and click again. Okay, the length, I am just look at this length. The length is 5.5 inch. So I can use the dimension, move, click on this line and move your mouse towards the upward direction. Click again and make it 5.5 inch. Okay, you can rotate your scroll to zoom in and out, and then dimension again. This is going to be 0.5 inch. And next you need to draw 2 circles. Circle number 1 is here. You can see a green dot there at the end of this middle line. Click there and make a 0.5 inch diameter circle, and on the other end of that line, that will be the same center as the half circle is. So click there and make it 0.5 inch once again, and finish the sketch, and then extrude this 0.25 inch. Okay, now save this file with the name the crank, crank, crank. Okay, so the crank is saved. You can click the save button. Now you see the next one is the rod, and here there is the hints is given here. You can edit the crank file to make it 9-inch long instead of 5-inch long, and save that as rod. So what I'm going to do, I'm going to edit the same file and save that with a different name and give the name as rod. So I'm going to save that, save as, and give a name rod. Okay, ROD, rod, and click on the save button. So the new file is named as rod, but I need to change the length. So I'm going to right click on the name of the extrude and edit the sketch. And now instead of 5.5 inch, double click on the dimension and make it 9 and press enter, 9 inch. Okay, so this is now longer. So finish the sketch and you can save. Click on the save button. Okay, save, replace. Something happened. I need to check again. Saved. Okay, so what happened? There is two files now. You can see here. One is the rod, another is the crank. So crank is there. You can double click and see the crank is shorter, the rod is longer. So I made the crank 5.5 inch. You can check the dimension here, which is 5.5 inch, right? And the rod, I edited the crank and made it 9 inch with a different name. I saved that, so there will be two files now. Click on save. After that, let's make the slider. This will be a kind of a cylindrical shape with a rectangular hole in it. As you can see, the length of this cylinder is not given, so we will approximately make the length as 4 inches. Okay, so go ahead and start a new drawing with English standard inch template, and then you draw a circle with the diameter 5 inch. Okay, so go ahead and start a 2D sketch. Choose any plane, but I'm going to choose the YZ plane for this drawing. That will be helpful. And start a circle at the center point. Draw 5-inch diameter, and then finish the sketch. Okay, finish it, and then extrude this, make it 4-inch length of this cylinder. Then on this surface, the circular surface, start a 2D sketch again. This time we'll make the rectangle like this. The rectangle will be 2.5 inch length and 0.75 inch width. Okay, so go ahead and use the center point rectangle, 2-point center point rectangle, this one, and click on the center point. Move your mouse, click somewhere, that is the random rectangle generated. So now add the dimensions. The width will be 0.75 and the length would be 2.5 inch, and finish the sketch. After that we need to make the hole, so we'll make a extrude 3-inch depth. Okay, so extrude, this one will be go to the inward direction, so flip the direction and make this 3 inches and click on OK. After that we'll need to make this hole over here. You can see the hole is located 1.5 inch away from the outer side, and it will be at the center point of the rectangular hole. So total width of this rectangle is 2.5 inch, but it is located at 1.25 inch from the bottom of the rectangle, which means that the circular hole is at the center point of this rectangle. So what I'm going to do, I'm going to select this surface. Okay, as you can see, this surface here is the rectangular surface, and then start to this sketch. You cannot see the rectangle here, so what I'm going to do, I'm going to click on the view and click on the visual style and change this visual style to wireframe. In that way you can see the rectangular inside. Okay, now what I'm going to do, I'm going to the sketch again, start a circle and draw a circle somewhere here, which will be 0.5 inch diameter. Then I'm going to add the dimension. So you see, this dimension is 3 inches and this dimension is 2.5 inches, right? So what I'm going to do, I'm going to add a dimension from here to here, making this 1.5 inch, and from here to the other side making it uh, 1.5 inch. I'm sorry, this one should be 1.25, so I'm going to double click on this and make it 1.25 inch. Okay, now finish the sketch and then extrude. You can use double-sided extrude, symmetric extrude on both sides, and drag this to the other end so that it makes the through hole. So you can change the visual style and see, click on the shaded with edges, and you can see this is make a through hole, but you need to make sure that it makes the cut hole, cut extrude. Okay, so click on this cut extrude and then click OK. So it will make the hole like this. Then after that you just click on the save button. I need to click on save as and give a name, which is the slider. So I'm going to copy this name and use this same name for saving this file. Click on the save button and going to click again. Now I'm going to show you how to create the pins. You will need 2 pins. So I'm going to file, starting a new drawing. You need to choose the English template, standard range, and then create. The dimensions for these pins will be 0.5 inch diameter. So you draw a circle on XY plane. Okay, draw a circle XY plane which diameter will be 0.5 inch, and then extrude this for 0.5 inch again. Save this with the name pin 1. Now I'm going to save this with a different name again. Save this with a different name pin 2, and then I'm going to edit the dimension. Go here and right click on the extrude and edit the feature. This time I'm going to make this 5 inch. Okay, this is pin number 2 and save this. If you go to the folder, you will find now 2 pins. Pin number 1 will be short, that is 0.5 inch length, and the second pin will be long, which is 5 inch. Okay, so once I have all the files ready, I see that we have the pin number 1, this one here, pin number 2, which is here. You can see the pin number 1 is 0.5 inch long, and the pin number 2 I can show you that is 5 inch long. Okay, the diameter is the same, but the length would be from here to here, which is 5 inch. Other than that, we have the base ready, the rod ready, the crank ready. The crank is longer than the rod, and the slider is ready. Okay, then save all the files. We have 6 files. You can see here the base, the rod, the crank, the slider, the pin, and the second pin. So once you have these 6 files ready, we can start the assembly. So now I'm going to show you how to do the assembly. For this assembly drawing, you need to create a new file. Okay, you can create a new file. This time we are going to choose the assembly, the standard assembly. You can see here the standard assembly in inch. Make sure you are in English templates and then choose the standard inch assembly template, and then click on create. Now you can see all the toolbars are different. So first you need to place the items, so you can click on the place. Okay, and then you need to find the files. I have saved all the files in the document folder. If you have saved somewhere else, you can bring them in the same folder. Okay, whatever the folder is, just bring them in the same folder. Now I'm going to click on the base and then click on OK, and then click somewhere on the screen, and then right click and click on OK. So the first one is here. Now place again. So you have the base, you can bring the crank, open, left click, then you need to right click, otherwise it will make a copy. So I'm going to right click and click on OK. Then place again the rod, open, this one is the rod, longer one, left click, then right click and click OK. Okay, and then place again the slider. Okay, bring it here, click, right click and OK. And I need pins, so click on the place, pin 1, open, click here, right click, OK. I need the pin 2. Okay, pin 2, open, click here, right click and OK. I will need 2 of this pin 1, so I'm going to place another pin 1. Okay, pin number 1 will be placed twice. Alright, so here we have all the files. Now we need to click on the save button and just give a name. I'm just keeping the same name, which is this assembly 1, and then click on save. You can click on yes to all and click OK. Anyway, because that message came to warn you that some of the drawing files may have been edited. Anyway, so now the first one here, you need to make it this one, the base, make it grounded. So you can right click on here and you can see somewhere it is written grounded. So right click and find the grounded and click this grounded. So look at this, you can drag anything. You can hold your left click and drag any of these parts, but you cannot drag this one because I have grounded. You can see a small pin over there. That's because I have grounded this. Okay, so right click on the base and make it grounded. Make sure it is grounded. The other parts you don't need to ground. Now I'm going to add a constraint. Okay, click on the constraint and then click on this surface over here and the other side of this base. So I need to find the other side. So I'm going to rotate this and find this side, and you can see a sound will pop, and you can see that 2 files are now on the same surface. So click on apply and cross that out. You can now try to move this one. It is moving, but it is sliding on the same surface. You can look from the top view and you can see this one is just sliding. It's not going left or right, it is sliding on the base. That's because the two surfaces are now attached to each other. Okay, you can go to click on home button. I'm going to click on the view tools and change the visual style with shaded with hidden edges or shaded with edges. That's make it more visible. Then I need to add one more constraint here. What is that? Go to the assembly again, the constraint. This time I'm going to add a constraint to this axis of the hole, to this axis of the hole. Once you see the axis, click on that axis and then click on apply. Okay, you can cross that out and try to move it. It is now constrained by the surface and the axis. Okay, so this is now have two constraints. You can check the constraint by clicking this plus sign and you can see there are two constraints. Okay, one is the matching of two surfaces, another is the matching of two holes. After that I'm going to add a constraint again. Okay, this time I'm going to use this one, the insert constraint, and use this pinch axis to this this one. You can see it is entered inside, but it's not serving my purpose. It is went to the other end, so I'm going to cancel it out and try again. Axis of the insert, then choosing this axis to this axis, but I need to change the alignment. Okay, you can just click on the opposite direction at it and it will insert into the hole. I'm going to do another thing. You can change the color of this, all the parts, so that all of the parts will be distinguishable. So I'm going to base and changing the material. Instead of changing the material, you could change the appearance here. Appearance, I'm choosing a different appearance here, and you can see that appearance is different. Anyway, this is not working, so I'm going to go back and keeping this as it is, but I'm going to change the material, making this a different material. The rod, I'm going to make it a different material. If you choose a different material or different color appearance, it will be more visible in the assembly. Okay, that's the reason I'm doing this. Once you change the material, make sure you click on the save button for every time. I'm just making this saved. Okay, slider, I'm going to make this with a different material. Just choose any material. This is just a practice. Save. For pin 1 and pin 2, I'm just keeping this same. Okay, so once you change them, you can see they are also changed in the assembly. Okay, click save. Every time after you make any changes, I suggest you to click on the save button. Okay, after that you need to assemble these two over here. So what I'm going to do, adding constraint, selecting this surface on this side and the other surface of the crank. This one is the crank, this one is the rod. So the rod is the longer one. Okay, so here on the other side I'm choosing this one, apply. After that I need to make sure that this whole, okay, this hole and this hole are aligned together. So I'm just choosing this hole over here, and um, it's not working. So let me try again. Constraint this hole, and I need to see the axis. So click on the axis. Once you see they are aligned with each other, click on apply, cross that out, and see whether they are working like this. Okay, click on the home button, and after that I need to insert this pin over here, right? So bringing this closer to here, constraint, click on insert, and then click on this axis over here and this axis over here, but make sure this is not going inside the whole uh, pin. So I'm going to cross that out. Let's try again. Click this axis and click this axis. Yeah, it works like this. Still it is little bit out, so I'm going to try again. You can use this over here and this over here. Constraint, insert. Okay, align. Alright, this worked like this. I can show you once again. Control C. Constraint, choose this axis here and choose this circle over here, and then I need to make sure that is insert and change this direction. It's not working again. Start again. You have to click on the insert option, then select this one and this one and change the alignment. Okay, now it is good. Try yourself, it should work. Click on save button and try this one. Try to rotate this, it's rotating like this. Okay, now after that you need to bring this open side closer to this one. So I'm going to bring it over here and bring this rod over here. So what I can do, I can so after that you need a middle plane in between these two surfaces inside the rectangular hole. So what can you do? You can find the slider here in the list and expand it and find the origins. You can expand the origin here and find the x y plane, because I drew the circle at the middle point. That's why this xy plane should be the mid surface. If you don't have this surface, you can go to the slider and then insert a plane just like this, mid plane between two planes. You can click here and then click on this surface over here, rotate this and click on the other side of that rectangular hole. In that way you will find the middle plane over here. Okay, so you can go over here and you can see in the assembly template you have the same middle plane. You can click on save button. Okay, and you can see you can change this to yes and click on OK. After that you need a middle plane for this one. Okay, so what can you do? You can go to the rod, the longer one, and here you can click on the 2D models and insert the middle plane just like that. Middle plane on this side, and you can rotate that and choose the other side. In that way there will be a middle plane here like this. So go to assembly and click on save button. Again it is asking for the edited version of that file, so I'm going to click on yes and click on OK. And you have this plan and this line over here. So now I'm going to click on the assembly again and then adding the constraint. This time I'm choosing this plane, the middle plane of the slider and the middle plane of the rod, and that's how it will become aligned with each other. Click on apply, cross that out. So this time it is moving, but you can see from the top that it is remaining on the same plane. It's not moving up and down, it's just remaining on the same plane. You can drag it and try it. Okay, so click on home button, and again we need another alignment. The circle, the circular hole to this circular hole. So click on constraint again, and this time I'm choosing this axis of the hole and the axis of this one. Okay, and apply. Close it out. Now you can see this is remaining on the same axis, but it's still not stable. It needs some kind of stability. So what can I do? I'm going to keep it, try to bring it back to the position like this, and then we are going to add another constraint over here, which is the middle plane of another middle plane, which is 90 degree to the previous middle plane of the slider. So which is basically the XZ plane. If you don't have XZ plane, go to the slider and add another middle plane from here, mid plane. This time I'm choosing this surface, and I need to see from this side, bottom side, and choosing this surface over here. Okay, now you see the another middle plane, which is basically the 90 degree angular with the previous middle plane. So click on save button, go to the assembly once again. You will see the same middle plane is over here. Now I need the middle plane for the base, so you can find the base. Where is the base in the list? Let me just move it. Okay, here you can see the base is here, so you can find the base. Under the origin you can find the XZ plane. Okay, so the XZ plane, you can right click and click it visible. If your XZ plane doesn't match with the middle plane for the base, you can go to base and insert the middle plane, just like using this middle plane option. Okay, and choosing this surface over here and this surface over here. In that way you will have the middle plane like this. Okay, go to assembly once again. So you have this one and this one. I'm going to use the constraint this time and choose this surface and the surface of the middle surface of the base. Okay, this way they will be aligned. Now try to move this. I'm going to cross it out. Try to move this, it will remain stable. Okay, now we need to insert this pin into the holes. Okay, one thing I'm going to do, I'm going to hide all the planes. So you can click on the plane and here, see here, right click and make it invisible. Okay, and right click on the plane, make it invisible. That will become invisible. Similarly, you can click here, right click and see invisibility. No, it's not showing, so I'm going to find the slider and right click on the name of the plane, make it invisible. Right click on the here and make it invisible. Same thing I'm going to do with the rod, making the plane invisible. I don't need that. So now I'm going to insert this uh, pin is into this circle. So what I'm going to do, I'm going to use the constraint, and then I'm going to use this axis and the axis of the hole here, and click on apply. This time it is now inside, but it's not completely inside. Okay, after the constraint to align the axis, you can add the insert constraint, which is the axis of this pin, okay, and the axis of the hole. Then you can add an offset of -2.1 because it's already inside the hole. I can add an offset of -2.1 and then click on apply. This is now inside the pin is now inside the hole. So my assembly is complete. Okay, you can click on here, hold your control key, select all, and then click yes and okay. This message is basically coming to make sure that you have taken care of any updates that you have made on the part files. So make sure all the part files you have saved them. Okay, click on save, click on save. Because I made some changes in this part files, I'm making sure that updated version is saved. Now I'm going to show you how to uh, make an animation and how to do the motion analysis. At this moment you can see this is moving very fine, but there is a problem with this with this assembly. You can see when it is coming closer, the rod and the slider is overlapping with each other, so there is an overlap or collision here. Okay, so we'll do the motion analysis here. How the before doing the motion analysis, we need two planes. Okay, one plane is for the base. I'm just clicking on the base, expanding it, and clicking on origin, and find the XZ plane. You can see this XZ plane is the middle plane of this base. So right click on that and make it visible. Similarly, find the middle plane or the XZ plane of the crank. So this is under crank. You find the XZ plane and make it visible. If your XZ plane is not matching with this plane, you can always go to the original part file and assign the middle plane from here. Okay, anyway, I'm going to the assembly again, and then if you have these two planes, the middle plane for the base and the middle plane for the crank, then you can assign a constraint. This time we are going to choose the angular constraint. Click on angular constraint and then click on this surface here and this surface over here, and use this one, solution of two surfaces. Okay, you need to click here to make sure, because you have two surfaces, make sure you have two surfaces. Click on apply, close that out. Now you see this is almost fixed. You cannot move it anymore. You can click and hold your left click and try to move it. It's not moving. That's because this angle is now fixed. Where is that matting? You can expand it and expand the crank or the base. You can see the last matting constraint is the angle. So you can always change this angle. Let's make it 15 degree. You can see this is 15 degree angle. You can make it 60 degree. You can see the angle is changing. Okay, so now I'm going to drive it. You can right click on that matting constraints, that is the angular matting constraint, and click on drive. And now from the start it's 0, end is 60, and then you can click on the forward button. You see this is moving and making a motion of 360 degree. Okay, you can make a multiple movement. You can expand this. You see the double arrow, click that and change this to number 10 and drive it once again. You see, this will drive for 10 times. Okay, I'm just clicking on OK because you have seen the movement. So again, I'm going to right click on the angle and drive, and then I'm going to show you how to record this movement. So you can expand it, make sure 10 times you have here, and from start point is 0, end angle is 360. Now click on the record button, okay, and you need to give a name to that recording. Okay, so I'm going to make name class as name 6 or whatever the name is. You can give any name. Okay, these are the record formats. You have two formats here. I'm just keeping it as it is, and click on save button. After that, you need to select the image size. I'm choosing the medium size. Okay, and then click on OK. Now you make it forward. So it is now making the animation. It will move for 10 times and make a recorded video or animation of this motion. Okay, so after completing this recorded video, I will show you how to analyze the collision. As you can see, it is having some collisions when it is touching the surfaces. The surfaces here with the rod and the slider, they are touching each other. At that moment they are having a collision. Okay, so I will show you how to adjust the collision and modify the design to avoid this type of collision. Okay, we are still waiting to finish 10 movements. After it completes 10 movement, it will stop rotation and it will save the recorded video. I'll show you the video as well. So okay, this is done. So you can go to the folder, and it's not there yet. It's under all files maybe. Okay, I'm trying to find the video. It has been saved somewhere. It is here, so I'm going to move it out. Control V. Anyway, when you save the file, make sure it is in the folder that you want to see. So I'm going to show you the video which is recorded. The video quality is not good enough. That's because the computer that I'm using right now does not have a proper video card. So this is not professional computer for making animations. If you do professional work in any industry, probably you will have a good quality video card that will help you to make a good quality animation video. Okay, so it will show the all 10 movements. Okay, anyway, so you need to make that video as well and upload on the module. Now I'm going to show you how to do the collision analysis. You can see here the collision detection. Click there, collision detection, and then try to move it. Okay, it will immediately stop. It will immediately stop movement when it sees the collision. Okay, so what can you do? You can edit the dimension of this rectangular hole and make the modification, and then try to analyze the motion again. So I'm going to the slider. Okay, then for the slider I'm going to change the dimension of the hole, the second extrude. Edit the sketch. In place of 2 inch I'm going to make it 3 inch. Okay, let's make it 3.5 inch. All right, so finish the sketch, and you can see the hole is not in the middle, so I'm going to edit the sketch for the hole as well. The extrusion 3, edit sketch, make sure that it is now, instead of 1.25, this is now 3.5 divided by 2, and this one remains the same. Okay, now this hole is at the middle. Okay, click on save button, go to animation, and then click on the save button once again. Make sure all of them are updated, so click hold your control key on the keyboard and select all of them, click yes and okay. Okay, now you see the rectangular hole is now bigger. Try to drive again, right click and drive. Try to drive again. It is still having the collision because I had the collision detection active. So what's next? I can try adding some uh, chamfer at this corner and this corner. So I'm going to find the slider in once again and adding some chamfer. Chamfer is here. Okay, let's add some chamfer over here. Make a chamfer distance 0.25 or make it 0.5. You just need to make some trial and error. Add chamfer on both sides. Okay, apply and go to assembly. You have the chamfer now, so try to drive again. Okay, this is working now without any collision. So try yourself, find a solution to avoid any kind of collision. Your solution may be different from mine, and once you have the motion without any collision, you save all the part files and the assembly file and then upload on the module. So you will have basically the part files for base, part file for rod, part file for crank, slider, pin 1, pin 2. So there will be 6 part files, 1 assembly file, and also you will have the video file. Okay, so you will have total 6 part files, 1 assembly file, and 1 video files. I will expect 8 files in your assignment submissions. 6 part files, the base, slider, crank, rod, pin 1 and pin 2, 6 part files, 1 assembly file, and the video file. Okay.